So section 11.3, this is combinations, okay? Order doesn't matter with combinations. So remember how last week I did like the 6 different ways you can organize the letters A, B, C, right? I put A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. 6 different ways that you can write those 3 letters. And we saw permutation says that all 6 of those ways are different, right? So I'll kind of write it just in case you don't remember, or maybe if you weren't here. But I said I want to organize these letters as many ways as I possibly can without repeating. And this is what we got. Okay, permutations says that there are 6. So 6 possibilities. Okay, I'm going to put it right here, according to permutations. Because permutation says the order in which you write it mattered. The order in which you wrote those things mattered. ABC is different than ACB. Like I can see that they're different, right? And that's different than CBA and CAB. So there's 6 different ways. Combination says, I don't care that they look different. You use the same 3 letters every single time. So I'm going to say one possibility. Whoops, let me spell that right. One possibility, according to combinations. Combinations sees a lot of these things as repeats. It'll look at ABC and ACB and say, those are the same. You're using the same 3 letters. I don't care that they're jumbled around. It's still the same 3 letters. So there's only one way to organize ABC, and that's ABC. Or CBA, but it's still the same as ABC, right? Combination says, I'm not going to distinguish between all 6 of them. I'm just going to say they're all the same, right? And I think, did I do the dollar bill thing with you guys? Okay, so the dollar bills, right? $2 bills, they were identical. Well, they're not identical, but they're both the same dollar bills, right? And as I flipped them back and forth, it didn't change the fact that they look the same. Combinations would say, it doesn't matter whether you're holding it like this or like this, it's still $2 total, right? Whereas permutations would have said, oh, this is different than these 2, right? Because the distinct bills are now in different positions. So that's the difference between today's lesson and what we did on Friday, is that combinations gets rid of the repeats. It gets rid of the repeats, okay? So here's your definition for combinations. Let me give that to you guys. So definition of combinations. Okay, given n items taken r at a time. And by the way, I will bring out the calculators once we're done, because that's going to be one of those things you're going to want to use. Taken r at a time, we have so n combination of r. I usually say n choose r, because you're going to choose a certain amount of things. So I always say n choose. Most people will say n choose. So n choose r is n factorial over n minus r factorial. Now, if you think back, so far that formula is the permutation. Okay, n factorial over n minus r factorial, that's the permutation. But remember how I told you that the combinations gets rid of the repeats? So here it is. You divide by r factorial. It's repeating that many times. So you divide by r factorial. Now remember what I told you. The nice thing about this is that you guys are going to be allowed to use calculators, so you don't have to know how to use the formula, right? We're just doing this the quick way. We're kind of running out of time here, so we're just going to learn it the quick way. Your calculators have that formula in it. So I think yesterday, or not yesterday, Friday, you had to press second times, right? And right above second times, if you had the little button for times, you would see an NPR. I think for the one today, I'm not sure. I think it's the plus sign. You're going to see NCR. Okay? So if you happen to have the same calculator as I did, you'll probably see it there. If you have like a TI, just go to the same place. You press the math button. And in there, you should be able to pick the combinations, right? So that's our definition for a combination. Okay? But again, we're just going to be using the button that comes with it. All right? All right, so just to make a note, it wasn't the plus symbol. You're going to press the shift button. Okay, so there'll be a button that says shift, and then hit the divide, and that's going to have the NCR above it. Okay, so let's say you wanted to do 5 choose 3. So for example, we're going to do 5 choose 3. Okay, so you're going to want to press 5 first, then shift division, and then 3. Now your calculator might be different, so if you have like a graphing calculator, you might have to press math and go into your probabilities, and then well, actually first you want to press your number, then math, probability, and choose R, and then after that you put the second number. What answer do you guys get? 7? Oh, 10. Okay, I was like 7's not right. Yeah, 10. Okay. Now, do me a favor. What's 5 permute 3? The one that counts all the repeats that are 60, right? So that's going to be 60. So here we go. All right, so that was 60, like you guys said. So 6 times as many results, possibilities. 6 times as many possibilities if you permute it instead of doing a combination. Okay, so you can see the difference there. Now, if you're thinking, well, wait a minute, you said that it's 6 times as many, but it's R factorial repetitions. R is 3. Isn't it 3 times as many? Well, no. 3 factorial is 3 times 2 times 1. That's 6. This comes out to 6. It's 6 times as many repetitions. Okay? So the R factorial is how many times it repeats it. All right, so let's do some examples. We're only going to do 3 like we did last time, just because that's pretty much the main 3 types of problems they're going to do. So example number 1, and we're going to find the number of possibilities. So find the number of possibilities. All right, so first one. So Deshaun has homework in, we'll say, 8 subjects. Okay, he only wants to do 3 of them. Does it matter which order he does the homework in? No, he just has to do 3 of them. It didn't say anything about like he has to do English and math, right? Or he has to do science and something else, right? No. If they said that, then it would be a permutation because certain things must occur, right? English, math, science has to be done. But here it doesn't say anything like that. It just says he has 8 assignments. He's going to do 3. Order doesn't matter. He just has to do 3 of them, any 3. So since order doesn't matter, then this is going to be 8 choose 3, which comes out to what? 56. So there's 56 ways to do that. Okay, and you can figure it out yourself if you want. It's going to take you a while, but you can say, okay, first subject, second, and third. Well, okay, first, second, and fourth. First, second, and fifth. First, second, and sixth. First, second, and seventh. First, second, and eighth. Okay, I've exhausted those. First, third, and fourth. First, third, and fifth, right? Start counting them all out. You'll get 56. Okay, I wouldn't recommend it, but you could. You could do that. So, all right, there's one example. Not too bad, right? Just like we did yesterday. I keep saying yesterday, Friday. As long as you write it out properly, just use your calculator, you'll get your solution. Okay? So a team of 12 basketball players needs to choose two people to refill water. How many different ways can you do that? So what should I write for this one? 12 choose 2, right? 12 choose 2. Yeah, so what did you get for that one? 66 different ways to do that, right? Now, if you were to do a permutation for that, what would you get, just out of curiosity? So 12 permute 2. 132. Okay? Twice as many, right? Twice as many. Which makes sense because 2 factorial is 2 times 1. Twice as many. That's because, let's say I got picked and Autumn got picked as the water people. Okay? They're saying, well, that's different than Autumn getting picked, then I get picked next. Is that really different? No, it's still just us two, right? So combination says, that's ridiculous. Why are you counting it like two things? It's still the same two people. It doesn't matter if she got picked first or second. She's still getting water just like me, right? So that's why combinations are important in some situations, right? Where order doesn't matter. It doesn't make sense to count twice, right? Just count the one, those two things as one because they're identical, okay? All right, so last one right here. So 5 out of 17 students, let me make this go up a bit. 5 out of 17 students will ride a car instead of a van. So don't let this confuse you because they mentioned 2 vehicles. They're just saying 5 out of 17 students are going to ride a car. Instead of a van, well, that's fine, but they're going to ride a car. How do I write that? So 5 choose 17, try doing that. What does it tell you? Yeah. It's because you're saying out of 5 people, I'm going to choose how many? You put 17 to choose from. Can I do that? No, right? Usually the bigger number goes first. So 17 people, 5 of them are going to take the car, right? So let's flip that. So this is going to be 17, choose 5. Because it's definitely not 0. I mean, I can pick 5 people, right? So what's 17, choose 5? 6,100 or 900? 188. Okay, a permutation would be 5 times 4, that's 20, times 3 is 60, would be 120 times bigger. Get that number and multiply it by 120. That's how much a permutation would count. Okay, so anybody want to give me that number, 17 permute 5? Because basically 120 times that. Everybody have it? Almost gonna pop. 5, 6, 8, 60. Okay, thank you. I mean, that's basically saying 1, 2, 3, 4, 5. So U5 right here. If I pick U5, but then the first time I pick Renee, and the second time I start with Destiny, and then next time with Sunny, right, and so on and so forth. They're counting that as different, even though it's still the same 5 people, right? In this case, it seems ridiculous. It's still the same 5. Why are we counting it 120 different ways, right? So anyway, this is what your homework is like. Okay, we're doing the combination part. Okay.